Okay, for each of these problems, you're going to see a box, okay, kind of boring, this little sum symbol, which means net, Fx equals, and a blank, and then you see acceleration in the x direction equals, and the sum of the forces in the y direction, or the net force in the y direction, and acceleration in the y direction. Now, this may look very difficult, but these are actually really not that bad. So the very first one has a 1 kilogram book is at rest on a tabletop. Diagram the forces acting on the book. Okay, so tell me what kind of forces are acting on the book. Force of gravity pulls down. And what other forces are acting on the book? Good. Force normal, absolutely. No more forces acting because it's not moving or anything. Okay, so we have this sitting on a tabletop like this. So overall, this is actually a pretty easy problem. In the x direction, which remember this is the x direction, the horizontal, what would be the total force acting in the x direction? Zero. Done. So is it accelerating in the x direction? Boop. Okay. Now let's look at FG and FN. What do we know about them on a flat surface where you're not going up or down? They're balanced. Very good. So when things are balanced, your acceleration is 0. And we know that these forces cancel out. 0. Okay? It's a boring thing. It's just a book sitting there doing nothing. Okay? Let's try... I'm going to skip down to doing, let's do the third one. Okay. Another boring box. Okay. And we're just going to be looking at the same exact things again. Okay. And now we have a 2 Newton force is applied to a 1 kilogram book in order to move it across the table with an acceleration of 0.5. So there's a lot going on here. Let's take it one step at a time. A 2 Newton force. So we're going to draw 2 Newton force. That would be our force. What do we call that type of force? Applied. Very good. Force applied. Okay. Tell me some other forces that are acting here. Friction. Very nice. Good. Does it say? Yeah, it says consider frictional forces. So force of friction is in there. What other forces are acting? Gravity. What else? Normal. Notice that they said specifically you could ignore air resistance, so we don't have to think about that. They also gave us this little tidbit of information. They gave us these, actually 2 pieces. They said it was a 1 kilogram book, and they said the acceleration is 0.5 meters per second squared. Okay. And the book is kind of being pushed in that direction. So it's kind of going along. Boop, boop. That's it moving. It's moving to the right. Okay. So what kind of information could we fill in? What do you think? Good. The acceleration in the x direction is 0.5. They gave us to that. Oh, oops. I almost wrote in the wrong spot. Okay. Other things you might be able to know, guess. Beautiful. I love the way she described that. It was gorgeous. She said the y direction forces are balanced. Okay. And when things are balanced, the acceleration is 0. And the net forces are 0. That leads us with the last bit here. Okay. Force in the x direction. Okay, now some people feel like, okay, we're going to have to do some math with the 2 and we solve for the friction and then we carry the 1 and we square root that. No, it's even easier. What could you do to find that? You have the acceleration. This is net force, remember. What equation do we associate with net force? F net equals mass times acceleration. Okay? You have the acceleration. Do you have the mass? Yep, they gave it to us in the problem. So this was 1. Acceleration is 0.5, 0.5 newtons. And as the kids say, Yahtzee, Yahtzee.